Welcome to the next part of the procedural building, and now let's scatter around some debris around the building and some foliage as well. To start with, I want to get an area around the building where it could be possible that debris or certain objects are laying around. To start with that, I'm going to go here where we have this geometry, and I would like here again to have this space. So I want that geometry, and I'm going to align it back to our plane. So here we have it now perfectly on the center. Then on the axis, I'm going to set it to no change. So by default, it will automatically fit all the axes to a certain center, but I only want to just place it nicely on the grid, so only y-axis. Then I'm going to use a poly expand node. So this works well with 2D shapes, of course. Then in this poly expand node, I'm going to set the output here to our surface. And as you can see, there is already a change here. We can increase this value as well. Let's increase it a little bit. And what is also very interesting in here is let's enable our wireframe. We can see that it automatically has this clean geometry when we do these expandings. This is super interesting with the poly expand node. Also further down here, we can decide what the output is. So I don't want the inside. So I now have the area around a building where props could fall. And with this offset here, I can decide how far a prop should go. But I think here, like something like this, 2.4 is good. Let's also reverse here before I go any further. Reverse that polygon. From here, what we can do is just scatter around props. So we can use the scatter node and scatter around points where items could be placed. Now at the moment, I found this a bit too random. So there is actually some interesting options in the poly expand we can use. So what we can do is we can have here the edge distance. So this is the distance, how far it is from its original shape. So the original shape was here, this inside border, and we can get a distance how far the outer points are. Let's also here set some divisions. So 22 might be too much here. Let's set this to 5. So we have some extra lines there. Now this value that I have here, we can see this is here as well in the attributes. So this is stored now in the vertex, but I would like to promote this. So attribute promotion. And let's put this into our points so we can easily adjust it. Then I'm going to use a wrangle node. And with this attribute wrangle node, I want to make a gradient based on that edge distance. So in my color, let's make a gradient. So I'm going to fit the value that is called edge distance. So this is our value I want to manipulate. And I want to set it in, and I want to make it to a new range. So currently, our current range from this attribute distance goes from 0 to 2.4. So the 2.4 comes from here, this value. That's important to know. So this is the same value. So that's the maximum it goes. But I want to change it so it goes to a 0 to 1 range. So I will change it here that it will goes to 0 to 1. And now as you can see, we have a gradient effect. To reverse the gradient, we can simply here do 1 minus, and now we have a reversed gradient. So important to know that if you are changing this value over here, this offset, you need to also make sure that this will change with it. So if you're familiar with vex and wrangles, you can then easily implement it as this as well. So we can quickly make a channel here. So channel, call it max value. But max value is nowhere created, so click this icon here. Now we have max value here. Then I'm going to right click here to copy the parameter. And in here, I'm going to then paste the reference. So here's the reference for that. So now when I change here, this offset, it nicely scales with it. Then I want to use this color in my scatter. So you can see by default the scatter will copy the color, but I want to use my color as my density attribute. So instead of density, I want to type in here my color. And now if I would increase my total count, you can see where we have this darker value, we would have less points scattered. Where we have a lighter value, we will have more points scattered. I would like to have maybe around 60 points. I think that will be enough. Now I have these points, and on these points I would also like to set a correct normal. I want them to face based on the wall. So previously here, I actually have here a template of my wall, and these are having the right normal faces. So I'm going to use an attribute transfer, and I want to transfer the normal direction. So in here, let's grab the normal node and plug that in here. And by default, it already gives us a nice output. So it gives us really the direction where each wall was. So we can also here focus on only exporting the normal. So we don't export any other data. There are also further here some conditions that we can play around with. As you can see, we have the range here, so range distance. Then further what we can do here is we can use another attribute wrangle node. And in there, I'm going to store our color as scale. So basically, the farther my point is from the building, the smaller the prop should be. So I'm going to just say add p-scale is equal to add our color. And let's say, for example, our red shell, because this color is of course a vector 3. Now one problem here is that let's look at our p-scale. The lowest value is very low actually. It's 0.05. So that's a quite small scale compared to our original scale, but compared to a normal scale. So this value, I can use a clamp feature. So I'm going to clamp this value. And the new value range should be from, for example, 0.5 to 1. So the lowest value now will be automatically 0.5. Or you can also just multiply the color, depends on what you would like to see or prefer. Also very useful here is to use the peak node. I'm also going to disable recompute normals. So points here will move along normals now. So it's very useful if you want to push this a little bit. Then this is then set up ready for instancing. So later I will come back for the instancing and handle all instancing at once. So this is my prop for, I probably will use this to place some foliage, like a few bigger foliage plants. Now I want to use a very similar process to actually scatter bricks around. So some broken fallen bricks on the ground. Then to scatter the bricks around, a very similar method, but I'm going to add some changes and I will copy paste this over here. So I can have a new version here. I might need to double check here if our link is correct. So we are looking at the polyexpand 2D number 2. And of course, this is 2D number 2. So that's correct. So what can happen is that our bricks can have a farther range. So let's maybe increase this to 5. So they can have a bigger range where they should fall. Then again, you're just going to do that gradient again. And we're going to scatter these points there. What I also found a useful trick is to use a color adjustment node. So it's just a lab nodes again. And with this node, I can actually here make sure clamp this from 0 to 1. And now I can play around with the brightness, the contrast. I can invert this. I can really like tweak still afterwards where everything is. So in this case, or what I tweaked the color to do is to only scatter on this area. So we're actually avoiding these other points. So this is a very useful node here to sort of define some of that region a bit more. So I can say like there will be more plants around the building, but there will be more bricks around the building. Then for the amount of scatter, I might lower this a bit. And on each point, I'm going to use a point replication. So what this does is it will create new points around points. So as you can see, each point has now a point cloud added, which is 100 points. I don't want that, that's a lot of points, so let's set this to 5. Then I want to go to the shape, and I'm going to set the shape here to the size 0, so it's actually flat now. And I can also play around here with the seed of the distribution. I can increase the scaling, like I can set this to 1.5. Then we can also fuse it. So in case points are too close to each other, simply fuse the points together. Then I'm going to add a random rotation. So attribute random, adding a random normal in here. And in the y-axis, I'm going to keep it 0, 0. So it doesn't change in the y-axis. And I'm just going to use a copy to points and copy a brick on. So I previously made already a brick. So let's grab one over here. And now I have a bunch of bricks there. So there are a few bricks here around the house. So if you would like to see more, we can simply adjust the scatter. And then next up, I want to actually scatter some debris models. So Pixel here has this nicely debris model. So you can find them in the library. So they have these really good looking debris chunks or bricks and so on. You could use more props here as well to scatter around. But I want to place down these big chunks around the house as well, close to the wall. So in here, I might use the setup that I did here. So let's define first an area around the house. And I want them to be actually pretty close to the house. So I will probably give this a very low value, like this. And I don't think I need that gradient effect. I can just go over the scatter one and scatter a few points. So I definitely want to have a few there. I think like this should be fine. Like 12, maybe play around with the seed so it's a bit more spread out. So I think this is fine. Then I want to copy this transfer node and I want to set normals on this so they are facing the right direction. And then on these points, I will copy that debris model. So here we have the debris model, and let's copy to points this to see if it will be placed nicely. And let's double check if this works nicely. I can see that they are quite small in scale, so I might set a P scale value. And so set the P scale value. Also notice that for some reason it will bricks by V from my original building. So let's create an attribute here for P scale and already set a correct value. You can also do the random noise and then set the randomized P scale value. So let's scale this up by 5. That's already better. So that's what I really want, is some of the debris pieces around the house. I think that's pretty cool to have. So maybe a bit lower, 3.5. I think it's better. So again, we can add random rotation, scaling, and so on. So I will instance this model. So I will delete this back again. And I will instance this then with a Unreal instance attribute. And further, let's add a ivy growing on this building. So previously on the bridge, I already made a ivy generator. And now I will do a very similar one. To start with this ivy generator, I decided to do a voxel based on my output here. So I want to voxel this output. So I have this result. Also, something important to know with a voxel is it will automatically bounding box to relative. So what this means, I will automatically scale this model down into a 0 to 1 range and then do a voxel and then put it back to original size. So if you don't want that, you're going to disable that here. So what we can do is we can set custom resolution. You can see it's getting super low poly, and we can disable here bounding box relative. So what will happen now is when my building is bigger, it will stay the same density. Or if my building is super small, it will keep the same density because it's not bound to bounding box. So it means it's not going to normalize the mesh before doing the voxel. So if you're disabling the setting, know what you're doing, because it can create a lot of high polygons. So in this case, I set it first to a custom low resolution, and then I disabled the bounding box. Then from this voxel, I decided to do a remeshing node. So the voxel just helps here to get a cleaner geometry, because I noticed that in some cases it might get some conflicts. If I immediately remesh this result, it might get some conflict. So this is a remeshing result. This is a quite interesting topology to work with. And from here, I'm going to again place down the gradient. So this gradient will decide where points should start. So let's do the same as before. So the starting points will be here at the bottom. If you want to have starting points, for example, at the top, we can then simply add a color here. And then we can also have starting points at the top as well. So, but it would make most sense, of course, that they would start from the bottom first. Then I'm going to do a group node, and this group will select all the possible starting points, all start points. This is a point group. We're going to now select points based on their color. So if they are smaller than 0.2, we select them. Then the range can then here control this area. Then we use a group range. And with this group range, we can then look at all the possible starting points. We can, of course, need to set this to point type. We want to work with points. And this is my start group or begin group. And now we can filter out points where starts are. I would also like to use here this feature and invert this. So now I can actually decide here how many starting points I have. So let's say I have 10 starting points. Now they're all together, but let's use a sort node here at the top. And let's set our points to a random, I set it here to a random seed. And as you see now, we have just random points here and there where things can start growing. Then I do another group range. I can just simply copy this one and change some of the namings. So in here at the starting group, I want to reverse this. Then I want to rename this to end. So the new name is end. Then what we can do here is we can actually, for example, copy paste this. So copy reference, and we can paste this in here. So paste reference, and let's say multiply by 10. So the more starting points we have, the more endpoints we have. So that is sort of like linked to each other now. And I can still tweak these values if I want more starting points or endpoints. Then let's use the find path again. So this node will bring it together. So our start points here are this, and then our endpoints are that. Then you will see a couple of lines. Then we're going to change the method here to any start to each ending. And then we will have this effect. So you can definitely see now we have these things growing around. Then I'm going to do a subtle smooth, because right now it's basically based on that resample. So without the smooth, it's just these hard edge lines. So with the smooth, it makes it a bit better, but I'm going to also just keep the smooth subtle. Then I'm going to resample the line because I want to create points for my Ivy cards. And I want to increase this to maybe 1.5. Then I'm going to use a fuse node. So fusing points together if they are close to each other. Then I'm going to do another loop. I'm going to do for each primitive. So this will basically loop over each line. So we have, in this case, 200 lines. So we have these 200 pieces. And what I want to do with this line is I want to create a gradient. So I want to have from a 0 to 1 range. So I can scale down my ivy the farther the plant goes. So let's use an attribute fob here. And the first thing we need to do, we can see that we have a nice start from 0 to our maximum points. So we have here point number and number of points. So point number is the current point, number of points is the maximum points. So I want to divide the point number with the number of points. And we can also see that this gives us a blue color, which means that it's an integer. So I will have to type integer to a float, because when we are in a 0 to 1 range, we want to have float values. So putting this in the color, we now have this 0 to 1 range. Then next up we can use the ramp, and we can use a ramp parameter. So click on this, and our input will be here, or 0 to 1 range. Then this ramp, right now it's a color ramp, but at the beginning here we can also just set it to a float ramp. So we have this interface. Then we can preview it here back into color, and we can see it's turned out to be all black, and that is because the ramp over here is not set up properly. So if I play around with this ramp, we can have a better result. Now what I also want to do is I want to save this immediately into a p-scale value. So I will use the bind export node. And I want to then export this into a p-scale. So now if I look into my sprite sheet, I have now here a p-scale value that is basically controlled by the ramp as well. So if I now view the result here of each branch, so I can see that they all have a nice gradient now. If I would copy a model on them, they would also nicely scale down. Then I'm going to use the orient along curve. So this will control the rotation. And I'm also, just to make sure we don't have that many overlapping points, fuse everything together. So let's copy 2 points, a grid on this as example. So we now have this effect going on. What we can do here as well is we can also add a noise in our p-scaling. So we can here set this to multiply it. And now we have multiplied a extra noise in there. So that could be something interesting. So that will be my ivy. So this will then also be used in an instancing. So let's place this over here. Now I'm going to handle the instancing. And as you remember before, I'm going to go back to one of my previous networks and copy paste the nodes for instancing. So in here, let's grab these, copy paste it. And now I can use it for my building network. So I have 3 things that I want to instance: my plants, my debris, and my ivy. So here comes in all the information from the plants. And what I can see is we don't have a up vector. So just to be sure I have a up vector, I'm going to set one myself. Then here, let's check the debris. Same here. Let's make sure we have an up vector. And here is everything fine. I have a normal, a p-scale, and an up vector. So then I only have to set these instances nodes. So as you remember from before, we're going to go in Unreal, right-click reference, and copy-paste it here. Here in Unreal, they are the plans I want to use. So right-click, copy reference, going back into Houdini, and paste it. So the same goes for other instances. Once that is set up, let's merge these nodes together, and I'll place a group nodes, and I call this instance points. Make sure it's set to points, of course. And this can be merged with the other ones. So now I have building with debris, destruction, and some plants growing around it. Now, going back here to this part, where I'm actually going to set the building back to its original position. So normally, without a problem, we can plug that in over here. And as you can see, now I have this building based on our position that I had here. Then there are a few more things I would like to do. Let's also add a color here for a vertex painting. So we can just use the noise, attribute noise, and we can store the color in our points. So I'm going to call 1D noise, and then we can do something like this. So I have a basic vertex code on here, so I get more variation in my tiling material in game engine. Now we can also increase the amount of polygons so we get a better result. So in here it doesn't have that many polygons to work with except for the corners, because the corners give a nice touch to our silhouette. Then also here, the problem now with, for example, the bricks on the ground is if I grab here my terrain, let's play the null node here to feel our terrain better. So at the moment my building is flying in the air, also my bricks are flying in the air, so I want to fix that as well. So what I can do is I can, for example, export the shape here from this. I can export this shape. So the poly expand shape, that can be interesting. And then we just project it into our terrain. So if I copy paste my poly expand, and let's also enable here the inside, I want to export this as my projection for my terrain. So I'm going to give this a group and call this to project. So this will be for terrain. Plug this in over here. So I can also define how far this should go. I might also here, these are my bricks, so I'm going to enable instancing here. And I'm going to create a group here as well. And this group is called ground bricks. And I will later lay them nicely on the ground. So let's now here view back again our full result. And now we have our full result, and I can use our split nodes here to get certain information. And I'm mainly interested in now in the project group. And taking my terrain, I can now project this into my terrain. So height field projection. And now I have the area of my building. And I also want to have a mask by feature, so we know with masks where the building are. So mask by feature, like this. And I like to here expand this selection, like so. Then blurring this out, based on the mask, of course. And I'm gonna have to be careful with this blur, so we still have enough area for our building. I think the value 1 in my case is good enough. Then next what I want to do is then use another split node here. And I want to filter out the bricks, so the ground bricks. And I want to project them on my terrain. So I'm gonna convert my terrain to geometry. So height field conversion. And now I can use the ray node to actually project the bricks better. So then we have a few options here. I can set this to, for example, minimum distance. So they will snap to the closest surface. You can also give this a better rotation if you want to. So I think this will be okay. So you can project other models as well if they would not align nicely on the grid. Now I'm gonna merge everything together and see if that works nicely. So my terrain, my bricks here, and my building. And I can see that that is better. So they're not flying bricks anymore, they're actually on the terrain. What you could do as well is you could have a better integration here. Like you could have some dirt going upwards to the wall. Then here again, to finish off my terrain, I'm gonna do the erode again here. So based on my mask. And as usual, I would disable my visualization, disable the cache, freeze this to about 2 or 3 frames, and click the reset button once more just to be sure. So we have some area, so we have some erode going on. And now I want to use my mask here, for example in the thermal. So mask on. And I'm also lowering some values. So it has some erosion going on. Then again, what we can do is we can do the copy layer, and I can save this into a new layer. So my mask, I can save this. This is my building area. So in previous videos I played around more with the mask, so you can do that here as well if you want that. So you can play the light field combine, and we can start combining different layers. Like for example something like this. So we have a very specific effect, and you can see we sort of had the feeling that there was like a drag or things were falling down this way because of the angle. So that's also pretty cool. So if you can use this later on if you want that. What could also be interesting here again to add is the blast node. So if you already previously did a road node, we might need to delete some of the layers so it doesn't conflict with our new road node. So then also here, clean up the mask. You can also save here this mask if you want to. For the moment I'm not going to save it, I don't think it was that interesting. But it can be a good idea to save these masks, of course. So then a few more things to do before we can go to Game Engine is I'm going to create a digital asset. So in here I'm going to right click, digital asset, going to call this procedural terrain, and this is my building node. Now we have here our parameter interface, and I want to add more outputs again. So I want to have 3 outputs for terrain, geo, and instancing. And as usual, we can create parameters. So for this case, I might skip this. Now let's create our outputs. So an output node for my terrain, then an output for my geometry. For my geometry, I will use a split node here again. And in here, this will be the last split node, and I want to split based on the instancing loop. So here, so only have this geometry. Now I want to combine these two then. So this is my real unique geometry. This will be group number 1. And then here, this is my instance output, which will be number 2. Then here again, I want to place these switch nodes. So we can turn on or off this node easily. So I have a switch node for my terrain, one for the geometry, and one for the instance. Then we also want to merge actually previous versions. So in here, I want to redirect the line. So I want to merge the previous geometry with my new geometry. Same for my instance. I want to merge my current new instance with the previous instance. And now like this. Then here I'm going to open the parameter interface from our main HTA. I'm going to create a new folder. So this is for our buildings. And I'm going to grab one of the inputs here. So this is my toggle to enable the buildings only. And again, copy paste this toggle. Also, small trick is we can select multiple nodes and then copy paste this one time. And they are set to both of them. Now that's set up, one more thing to check this in before I can go in Game Engine is I need to set the materials. So here I have my building, but I need a material from Unreal. So in here, we're going to copy paste the path from my material. So here is my material, my brick wall. I'm going to right click, copy a reference, go back in Houdini and copy paste it here. And that's set up. Oh yeah, one more thing here as well. I want to have a custom input. So object merge node. Gonna take one of the if switches over here and use that here as well. Then in here, exposing the object merge node and calling it placeholder buildings, clicking accept. So this is now ready to get a test in Game Engine. And in Unreal here, I've rebuilt my asset and I can see my building is working. So I have my building itself with my material on it. I've also have the ivy here growing on it. So it's also cool to see. So we can maybe still play around later on with like the scaling and the seed and so on. Or maybe push it a bit more out of the building because I feel it's like inside the building too much. So also here I have my debris pieces and my plants here. That also works nicely. When I first actually opened the building in Unreal, there were a few issues. So the main issues that happened were based on normals. So first thing I noticed here with my instancing points is if I hold my mouse button, the normal is actually stored in the vertex at the moment. And one other problem with that is when I go to the vertex, it's actually empty. So that was the problem that I noticed, is that the normal was not really there. So what I decided to do is I used the attribute rename node and I named the normal to normal backup. So I have actually a backup of the normal in case anything would go wrong. So the problem can cause here when I merge everything together, there might be some conflicts, including the normal. And as you can see here, the normal is stored in the vertex. So afterwards here, I still have my normal backup and I would call it back to normal. So basically restoring my original normal. And I'm also enabling here override existing attributes. So that makes sure in here that I have these right directions back again. So this was my originally calculated normal. So that was one of the issues that helped. And also further here, I actually cleaned up my attributes again, just to be sure, because I noticed that there is a lot of information going on, because when I merged my attributes with my building, it created all these. So just to be sure, staying consistent with the attributes, clean the node. I'm also going to do the same here for my geometry. I had a lot of attributes here going on, so I decided to clean it up in only the necessary attributes. I've also placed down a divide node to triangulate the mesh, because Unreal really likes either quads or triangles, so in this case I make sure I triangulated the mesh, and I've also added a normal, just also being sure that we have normal information, because that's quite important when you're merging geometry with instancing points together. So then when I rebuild my asset, it's then nicely here placed and integrated. One thing we could also, for example, still improve is the path here. So I placed my building next to the path, which would basically like override this part. It would be possible to detect these stones and then use a ray node to then project them on the terrain, just like we did here with the bricks. So we can integrate things with each other. So since this is one big tool and we have all the information in one big tool, we can then easily switch information out between different HDAs. But so that was it for this video. Thank you for watching and I hope you enjoyed it.